Let's go ahead and continue on with lesson 4.6. We left off talking about exponential functions. Now we're going to apply those to some situations here. And so to first start, we'll revisit another idea called relative change. And so looking at this situation, Ebola breakout in West Africa, we have the number of cases in 2014, and months later there were now 234 cases reported. And so now the question here is, what's the relative change between the two cases? You need to remember that that's the new value minus the old divided by the old value gives you the relative change. And so now we're talking about 80%. Relative change, as we kind of talked about before, can be considered as a percent. And in this case, it's a percent increase, or what we call a growth rate. And we'll use it to find an exponential equation. Again, remember, an exponential equation had that form. We have a form for the exponential equation as y equals. And so an exponential model, what we're talking about here, an exponential model looks like y equals a times b to the power of x, something of that sort. That's an exponential model here. Use the model to predict the number of cases after 6 months. And so looking at this here, since there was 80% change in 1 month, we would then write it 134, your starting value, times 1.80. That's your percent growth rate. And so you can see I have this kind of math over here where I get the 1.80 from, and raise it to the power of 6 for 6 months. And then you can see around 4,500 cases of Ebola in 6 months at that 80% growth rate. Now let's compare that to a linear equation. What would we do if it was a linear equation instead of an exponential model, a linear model? You would have those two starting points. You would find the slope, and then you can see with the slope here, you would end up with 104 cases per month. 130 because that's that starting value, right? Where C is the number of cases, and so after 6 months, you would have 754. That's vastly different than the 4,000. So again, it depends upon what model we expect this growth rate to be. Is it constant linear growth, 104 per month, or is it 80% growth? What would each model predict after 2 years? You can see you have way different values here. This giant number, 179 million after 2 months if it's 80% growth rate, versus 2,626. Again, which model would be the one that people would use to predict exponential or linear? It's kind of tough. We need more data. We only have 2 data points. It would have been nice to have a third data point for us to determine that. The next one, world growth, you're going to try to do, that's what you're going to do for the discussion. And so you'd have to find that relative change. You'll see it's increasing. And so you would find an exponential model similar to what we did here on this problem for number 10.